Cone plant setup. The intent of this video is to go through what is required to ready this plant for work. Before your CEC cone plant arrives, you need to have the blocking package of support timbers as recommended by CEC on site. First, move the plant to a level, compacted, stable operating site. Place the machine so its feeder is as close to the feed source as possible. This placement increases production by shortening the loader changing cycles. Now that we're at the hypothetical operating site, put a block under both front hydraulic setup legs. Note, the electrical oil heater system should run during the setup. You must first check the cone fluids and oil level. After checking the levels, start the electrical system to run the hydraulic legs. Set the legs down until you can release the delivery truck from under the plant. Once the truck is gone, bolt on the front support legs and their braces. Turn on the oil system and let it warm up. Check the oil flow for return oil. Check the input temperature and the output temperature and the oil pressure. Recheck these after the warm-up to see that it runs in spec. The cone will not start until it has had 20 minutes of warm-up time. This protects the cone from quick starts and cold oil damage. Next, place blocking under the rear hydraulic setup legs. Raise the rear of the plant to provide conveyor clearance. Level the machine left to right, then raise the front legs to level the frame front to back. Now place cribbing block under all support jacking legs and under the front support legs. Use your hydraulic legs to raise the plant while adding the blocking. Be sure that your plant is level front to rear and side to side. This will help ensure that the material will flow properly, the feeder will feed evenly, and the cone will feed and discharge properly. Let's now look at what we've done. The crusher is blocked in the rear, in the front, and center. It's also blocked at the end of the feed hopper. This allows for the proper machine operation and material flow. Then adjust the skirt board rubber on all the conveyors to provide 1/16 inch clearance between the skirts and the conveyor belt. Now check to make sure the crushing chamber is clear. Check your adjustment to be sure that the cone is set to produce the product you intend to make. Look in the feed hopper to be sure that it is also clear. You will need to raise the screen and feed conveyor to the operating position. You're now ready to test run the cone plant. Engage the screen and conveyors by using the electrical control box. Cone plant belt drives and oil safety. Cone crushers, their screens, and conveyors are all belt-driven. Belt drives will stretch 3 to 4% of their length during their useful life. This means that you need to adjust the belts regularly. Belts will stretch most in the first 100 to 150 hours of operation. The belts should be checked every 10 hours for the first 50 hours of operation and adjusted to your manual specifications for proper tightness. If you do not do the adjustment, you will experience belt stall that will shut you down when the crusher is loaded, costing you more time and delays than if you did the adjustment. After the initial break-in period, you should check the belt tension weekly to make sure everything is proper. Never adjust the belts with the machine running. Your cone crusher has two oil temperature gauges. One shows the oil temperature into the cone, and the other shows the oil temperature out of the cone. These gauges tell you how your cone is running. The temperatures should not differ more than 5 degrees. If they do differ more, you need a technician to check for trouble. You also have an over-temperature shutdown switch that is set at 140 degrees. If the cone temperature exceeds this mark, the cone will shut down. You will then need to find the cause of the raised temperature. Another feature on the CEC cone is a low-temperature oil switch that will not allow the cone to start until the heaters raise the oil temperature to a minimum of 60 degrees. This assures good lubrication at startup. You need to check the oil safety system on a daily basis. Do this by starting the oil system and cone. Read the temperature gauges and oil pressure gauges. See that they are at normal startup temperatures and pressures. Now, turn off your oil pump and the cone should shut down in 10 to 12 seconds. If it does not shut down, your safety system needs repair. The repair needs to be done immediately so you have proper protection. Always reinstall all guards when adjustment is complete. Safety is our goal. Cone adjust. The CEC cone has many advantageous features in its adjust and clearing system. The standard cone items are manual unlock, hydraulic adjusting, and hydraulic clearing. CEC cone adjustment is fast, simple, and easy to perform. To adjust the CEC cone, you first need to have the cone turned off and the chamber empty. Next, loosen the top shell locking bolts until you have relieved the thread lift that you experience when locked. Grease the threads at the 4 Zerk fittings 6 pumps twice a week. The cone adjusting ring has 2-inch buttress threads in its inner surface. The bowl has 2-inch buttress outside threads. The rotation is done by 2 opposing cylinders mounted 180 degrees apart, pushing on the drive legs on the outside cover of the cone bowl. Each cone has a measured movement per drive lug. You can measure the adjustment of the cone by referring to the operator's manual. The movement of one drive lug distance is 0.039 inches on a standard cone and 0.033 inches on a shorthead cone. Index 25 lugs per inch of adjustment. The adjustment procedure is as follows. Loosen the fixed locking bolt on the cap. Release the manual lock. Next, you direct the spring-loaded adjustment cylinder to face the direction you wish to adjust. Tighten the first cylinder left, tighten the second cylinder right. Start the hydraulic power unit. Retract the cylinder until it drops in the most retracted index lug opening. Move the control lever the opposite direction. You will get 1 lug in movement per stroke of the cylinder. The cylinder is spring-loaded into the index lug cavity and automatically resets itself when retracted. After you have moved the cone bowl the appropriate distance, do the following. Retract the hydraulic adjustment cylinders. Turn off the hydraulic pump. Reset the manual lock. Retighten the fixed locking bolts to the proper torque. Run 4 test balls of aluminum foil through the running cone to confirm your setting. CEC Cone Clearing System. CEC cones have a proven spring tramp iron protection system. This allows 3 to 3.5 inches of adjusting ring vertical movement in order to pass an uncrushable item. This system requires nearly zero maintenance. The CEC spring system does not break, does not leak, does not have to be recharged, and does not have vulnerable exposed hydraulics. Just big, durable, maintenance-free springs. Let's put ourselves in the worst position. Let's say you have a large piece of tramp iron in the chamber and it won't pass. First, stop the rock feed. Crush the chamber empty. Shut the cone motor down. Use the 8 hydraulic clearing cylinders to raise the adjusting ring up to 3.5 inches around the complete cone. Use your hook and pull the tramp iron to the center. Remove the tramp iron from the cavity. Lower the jack. Return to crushing. The time needed for clearance? Just 10 minutes. A cone operator will tell you his worst nightmare is to stop his cone fully loaded. Not so with a CEC cone. Let's say that you experience interrupted power supply and this in turn shuts your cone down fully loaded. The CEC cone forgives you, and it does so quickly. Raise your clearing cylinders to the maximum height and release them. The relief springs make the rock in the chamber crush. Do this 3 or 4 times and you'll hear the rock crush. Usually by the 4th cycle, you can hold the cylinder up, start the cone, and lower the cylinder to the crushing position. Then start the rock flow and you're back to crushing. CEC Cone Lube System. CEC cones have an external cone oil tank that holds 110 gallons of oil. The tank is mounted midship on the cone plant frame for best ground clearance. The oil tank has 2 4.5 kW enclosed oil heaters that you turn on each morning that will preheat the oil to a minimum of 60 degrees before startup. The cone plant is equipped with 3 gauges: oil temperature into the cone, oil temperature out of the cone, and oil pressure. You can lift the lid on the oil tank and observe the return oil flow from the cone. This is always important to ensure that everything is proper. If you observe any unusual oil pressure, you need to observe the return oil. The oil temperature range on the cone is 60 degrees at startup to a maximum of 140 degrees hot weather operating temperature. CEC cones are equipped with a fan-cooled hydraulic radiator and an oil cooler that automatically turns on when the oil reaches 105 degrees, maintaining the oil in the safe working range. CEC cones can perform at maximum in the hottest climates without oil temperature problems. CEC cones have a working range for oil pressure. Minimum for all cones is 10 psi. Maximum for 36-inch and 40-inch cones is 20 psi. Maximum for 48-inch, 51-inch, and 60-inch cones is 25 psi. CEC cones also have a lockout system that will not allow the cone motor to start until you have 10 psi oil pressure. Safety system. If the oil pressure drops below 10 psi, the crusher motor will shut off until you correct the low oil system problem. The systems are equipped with an adjustable pressure relief that allows you to raise the system pressure and compensate for crusher wear. The relief is to control the maximum pressure. Let's review what you need to know. Check the oil tank level. Turn on the oil pump and heater. Wait 20 minutes for the oil temperature to reach 60 degrees. Check the return oil flow. Check your 3 gauges: temperature in the cone, temperature out of the cone, oil pressure. Now you're ready to run your cone. Cone liner change. CEC cone liner changing is the easiest in the industry. The bowl and mantel surfaces are machined. The liner surfaces are machined. They fit up metal to metal on the machined surfaces. The mantel locks down with the head nut and spacer assembly. The bowl liner locks in place with the U-bolts. Note: no backing material is required to lock the liners in place. The advantages are no cleanup of old backing material, no pouring of backing material, no temperature controls on liner change, time to change liners reduced 50% or more. Let's start out with a look at a liner change. We're going to use a bare cone on the ground for demonstration purposes, but the steps are the same after you clear the overhead conveyor and screen feed lip on a cone plant. Removing the bowl is very simple. First, release the manual lock, then the locking bolts to relax pressure against the adjustment threads. Rotate the bowl with the adjusting cylinder to unthread and prepare for liftoff of the crusher main frame. Now that the bowl is unthreaded, remove the feed hopper and set it aside. Set up the floor with 2 4x4 beams to land the bowl on for liner dropout. Set the bowl over the 4x4s and drop it to rest. Remove the covers for the U-bolts. Take your air gun and loosen the U-bolts. Shift them clear of the liner hooks. Set up the new liner over the 2 4x4 beams, the width of the liner, so the bowl will be able to drop over the top surfaces, allowing clearance on the edges. Clean liner surfaces with a power wire brush to clean off any dirt, rust, or other foreign items. Lift the bowl in the air. Check that its face surfaces are in good condition and are clean as required. Lower the bowl over the liner and shift it to set down properly. Hook up the U-bolts and tighten them in a corner-to-corner pattern, like north-south, east-west. This will pull the liner in place. Make sure it seats evenly. Now tighten all U-bolts. Use silicone to reseal the covers. You're ready to reinstall the bowl as soon as you change the mantel liner. Mantel change procedure. With the bowl removed, lift the head assembly out of the cone. This is not required for the mantel change, but it allows you to do the inspection of the sealing ring, the support spring and housing socket liner, and replacement of the sealing ring. Remove the socket sealing ring. Inspect it for cracks and broken sealing surfaces. Replace the felt sealing ring. This keeps dirt out of the crusher. Clean it and replace it with grease. Remove the springs and housings. Clean out the mounting and lubricate with oil. Reinstall the springs and housings. Replace any that are worn or damaged. Inspect the socket liner for wear. You should have a good running face with good outside oil sealing face. If these are worn out, replace the liner. With the shaft elevated, look at the head ball of the cone and sealing ring faces. If they're dirty, then clean them and lubricate them with oil. Check the oil passage to the head ball. Place the shaft downward in a cribbing square or in a stand so that you can work on the head. Remove the bolts that hold the feed plate in place and remove it. Put the head nut wrench onto the head nut and use a sledgehammer to loosen. If it won't loosen, cut out the torch ring to relieve the pressure on the nut. Remove the nut and spacer. Bang the old manganese to loosen it. Weld on 2 lifting eyes and lift off the old manganese. Clean up the head with a wire brush and clean and grease the head nut thread. Clean the head nut threads and grease them. Weld 2 lifting eyes on new manganese and clean the underside. Lift onto the mantel assembly. Square it up and set it down on seats. Install the head spacer and the new torch ring. Install and tighten the head nut. Install the feed plate with the new bolts and torque bolt tight. Remove the lifting eyes from the liners. Reinstall the socket sealing ring. Check the clearance and rotation. Reinstall the head into the cone. Make sure to seat the head properly on the sealing ring. Check it for free movement. Grease the threads. Reinstall the bowl on the cone and turn down to the setting required. Relock the fixed bolts to lock the adjusting threads. The job is complete. As you can see, the liners have lots of contact surface, metal to metal, and no messy backing compounds. The liner change is much faster and can be done without having to concern yourself with weather and temperature that are a problem with backing materials. CEC liners come in two quality ranges, either 14% normal manganese content for normal to severe crushing, or 18% manganese for very high abrasion crushing material. CEC liners are available in coarse, standard, and fine liners to fit your standard head cones. CEC has a large stock of liners on hand and can most likely ship on the same day you place your order. If you have any questions on installation or service, please do not hesitate to call CEC's service department. We want to be your partner in good performance. Clutch adjustment. CEC sells machines that have diesel engine drives with multi-plate disc clutches. These clutches need to be operated properly and adjusted regularly. Let's discuss these needs. Clutch operation. When you are going to activate the clutch, you need to reduce the engine RPM to 1000 RPM. Next, do not lock the clutch in without following this procedure. Partially and momentarily engage the clutch to start movement of the crusher. Your crusher may be a jaw or impact crusher. Both types of crushers have very heavy crushing members and need to be handled in a similar manner. Re-engage the clutch several times. Raise the crushing member RPM toward its working speed. When you have raised the speed of the crushing member to a level that does not lag the engine down, engage the clutch fully. Next, increase the throttle setting to the full working RPM. High RPM engagement and direct full engagement of a clutch will cause almost instant failure. Clutches are not forgiving, and CEC does not warrant misuse. Clutch adjustment. All clutches that are used by CEC on their crushers require regular adjustment. A new clutch needs to be adjusted to its proper torque setting before being put into service. Every clutch has a setting range that needs to be strictly observed in order to operate properly. Normally, the cover plate of each clutch gives you the torque setting for this particular clutch. You need to be sure that you follow these settings. In order to make a clutch adjustment, the machine must not be running. Always have the clutch disengaged during adjustment. Remove the clutch inspection plate and read the setting requirement on the plate. Use the settings listed on the plate rather than what the manual may say, as the plate settings are for this specific clutch, and the manual may cover a different type of clutch. However, if you have contradicting specifications, you should verify the setting with the factory. You need to refer to your manual for the step-by-step procedure of proper clutch adjustment. We're going to show a clutch that we have in the CEC shop today. This will give you the procedure, but does not take into account the differences in the release method of clutch adjustment rings. There are two common release methods for adjustment rings: push-pin release and the cam overlock. We're going to demonstrate the cam overlock. You use a screwdriver to release the cam lock. You then use a pry bar to adjust the locking nut. Upon completion, you release and relock the cam lock into the adjusting nut, and then move the nut to make sure you are locked. The push pin works the same, except you pull the pin to adjust and push it back to lock. After adjustment, use the engagement lever and engage and disengage the clutch 4 times without the engine running. This allows the clutch to accept its new torque setting. Torque adjustment is the only way to check a clutch to assure it is set properly. Now, place the torque nut adapter over the clutch operating shaft. Place the torque wrench over the operating shaft adapter nut. Stroke the torque wrench and measure the foot-pounds of torque it takes to engage the clutch. Compare the measured foot-pounds of torque to the specifications on the clutch plate. If they are proper, you have completed the adjustment. If not, reset the adjustment to the proper foot-pounds. Recheck to ensure the locking pin is in place. Reinstall the clutch inspection plate. Remove the torque wrench and torque nut adapter. Reset the torque wrench to 0 for storage. Follow the maintenance manual for frequency and use the feel of the handle pressure as an easy alarm for resetting. A new clutch needs to be checked daily with a torque wrench and adjusted each 10 hours for the first 50 hours of operation. CEC is providing you with a suitable torque wrench for this clutch. A clutch usually needs readjustment weekly after the initial break-in period. Some operation requires more frequent adjustment. Use your torque to establish the frequency needed for your operation. You must follow the procedure as we have outlined it if you expect normal clutch life. CEC does not warrant misadjustment or misuse. Let's look at one of your crushing plant's biggest problems: belt adjustment, belt training, and skirt board adjustment. Let's take a conveyor and walk through the proper sequence of setup. First, we need to adjust the feed box skirt boards. These need to have a clearance of 1/16 inch between the belt and the skirt board. A hacksaw blade is a great gauge. If the skirt boards are too tight, we get welding, which causes bad belt tracking and over horsepower use on the drive motor. Next, tension the belt. Remove the lower side guard to gain clear access. There should be normally 3.5 inches to 4 inches of belt sag between the return idlers. The idler needs to be square to the conveyor frame. The head and tail pulleys also need to be square to the conveyor frame. The tensioning is done by the bottom belt adjustments on the standard conveyors. Replace the side guards when adjustment is complete. Belt tracking is accomplished by steering the troughing rollers. Advance the opposite edge forward to force the belt over and cause the belt to run true. Look up the belt and steer the roller like you are steering a bike. The belt will respond. The motor to gearbox drive belts will need adjustment. The standard formula for adjusting is to measure the belt's centers. Example, 15 inches. Adjust the belt to have 1/64 of an inch of sag per inch of center distance. This works with all V-belts on conveyors and stackers. Note, CEC uses Dodge gearboxes on all conveyors and stackers. You need to check the oil level of these boxes before startup. Shipping on some conveyors requires the boxes to be without oil. Check yours before running. Consult your Parts and Service Book Dodge section for proper lubrication and oil level. Belt splicing. In order to help you learn new service techniques with a crusher and screen, we will show you how to splice a replacement conveyor belt. Measure the belt length or consult CEC for the proper lengths. Be sure you order the ends cut square to the side so you do not have to recut the ends, causing the belt to be too short. Open the belt ends up so you can work with them. Take one end, square the punching template to the belt, and nail it through to a 2x12 beam for support. Take your belt punch and punch the holes in the proper location. Note, this is very important. You must use the combination of proper tools when punching a belt. CEC uses 140, 150, and 190 Flexco fasteners. Use the proper 140 template, 140 punch, 140 fastener, and 140 tape size in order for your splice to be proper. You will need a tightener wrench and bolt breaker also. Repeat the punching sequence on the second end of the belt. Square the template and nail it down. Then punch the holes. Next, remove a troughing idler at a point where you're going to do the splice. Put a 2x8 across the frame so you have a working place. Thread the belt on the conveyor. Use conveyor clamps and cable come-alongs to bring the ends together. Install your proper-sized Flexco fasteners loosely, starting at the middle and working outward. Clip the corner of the belt to eliminate hang-ups. Install the joint tape. This runs completely around both sides of the belt splice seam. This seals dirt out of the splice and keeps the splice from rippling. Tighten the locking nut snug. Do not over-tighten, as it will cause the belt to create misalignment. Use your bolt breaker to remove the surplus length from the fasteners. Use a small air grinder to smooth the bolt-to-nut area. Tension the belt. Adjust the skirt board and train the belt to run square on the head pulley, tail pulley, and idlers. CEC manuals have a very good section on belt adjustment, training, and drive tensioning. Refer to these for additional information. Wrap drives are different. You only square the head pulley with the bottom adjustment. You tension the belt with the wrap drive adjustments. This gives you tension and increases the wrap on the head drive pulley. This allows additional horsepower to be transmitted to the belt, giving you more tons per hour. CEC belt speeds are normally 250 feet per minute, but this can be increased when job conditions require more tonnage. Improper belt tension causes the centers of head pulleys to fail. It is important to maintain proper belt tension to avoid this. In the event that you need to change a head pulley on a closed-circuit cone or impact plant with a wrap drive, you need to know how to do this without taking the belt apart. When a machine has a very tight belt, you may need to remove the wing tail pulley to gain enough slack for the drive pulley removal. Relax all belt adjustments to give you maximum belt slack. Remove the snubber pulley. This gives you about 10 inches of additional slack. Make up 2 spreader bars as shown. We recommend round bars for strength with welded-on washers. They need to be of sufficient length to allow you to clear the obstructions and get the come-alongs hooked to the bars. Insert 1 spreader bar above the head pulley. Insert the second spreader bar below the pulley. Fasten 2 cable come-alongs to the spreader with the pull-up and 2 to the other spreader with the pull-down. Tighten the cables until you've made enough room to remove the head pulley. Unbolt the drive, gearbox, and belts. Remove each of these. Unbolt the head pulley bearing on both sides. Now you can remove the head pulley. Reinstallation is the opposite procedure and will go more easily than the original removal. The complete procedure, including head pulley changes with the shaft, should not exceed 6 hours, with 2 men and a service truck with a crane. Call CEC if you have any procedure questions. We can help you. Tail pulleys are changed in the same manner, except that they do not have any drive components. Screens. Screens are used to separate rock products by the size of the cloth installed. If the product can fall through the screen cloth, it moves to the next level. If it does not fall through, it exits off the discharge lip. The CEC screen shown here is a 5x12 screen. It consists of the following parts: screen basket, screen suspension and support, eccentric mechanism and drives, drive guards, and subframe. This screen is a customer's unit to be installed on an existing crusher. It replaces a vibrating feeder. The top screen lip will feed the crusher. The second lip will feed the bypass chute, and the throughs or reject will exit the underconveyor. Look at the frame structure and channel frame mount. This will slide onto the customer's crusher frame and bolt down. It will require minimum adaptation. The frame is complete with access ladders, walkways, railings, and kick plates. CEC makes two types of screens: a welded construction style up to and including the 5x14 size, and a huck riveted style with replaceable decks on the 5x16 and larger sizes. CEC makes screens from 3 feet by 6 feet to 6 feet by 20 feet in size. Now let's look at the screen basket. It's a welded construction, and the cross members are the screen deck supports. The screen has a special step deck to cause a tumbling and cleaning action as it screens. All CEC screens have feed boxes for the material to enter and take the impact off the screen cloth. They have discharge lips to feed chutes. This screen has special purpose, customer-required discharge lips. Next, let's look at the screen suspension system. CEC uses Firestone vertical rubber coiled spring mounts. These are sized for the particular screen weight and loading. The rubber screen mounts maintain the ability to rebound under maximum load, unlike coil springs. The coils press closer together, bottom out from the weight, and lose their bounce back. CEC also uses corner mounts on all of its screens. The mounts bolt to the screen sidewalls and subframes with steel plates. In between the plate and vulcanized to the plate is a rubber spring support. The support's first duty is to keep the screen in proper alignment at all times. It controls the critical vibration during startup and shutdown by minimizing the screen movement as it gains RPM or decreases RPM. This function is particularly important when screens are installed in tower steel structures. Some of CEC's competition has now started using Firestone vertical rubber spring mounts. They charge several $1,000s extra for what CEC gives you as standard equipment. The CEC screen shown in this video is an incline screen. This screen has a 12-degree screen deck slope. The screen leg length in the mounting accomplishes this slope. CEC makes 12-degree screens, 15-degree screens, and 18-degree screens. CEC also makes flat screens in 5x14 and larger sizes. CEC makes heavy-duty grizzly scalp screens for riprap or dirt separation. Now let's look at the screen eccentric. This is the mechanism that causes the screen to vibrate. CEC screens have a 45-degree to horizontal stroke. Along with the incline, this stroke causes the product to travel down the screen so the material can be separated. The screen can run at different speeds as required. CEC's eccentric system can be run at one of three speeds: 820 RPM, low speed, heavy rock; 940 RPM, medium speed, medium rock; 980 RPM, high speed, maximum separation, light rock. CEC has the ability to vary not only the speed, but also the counterweight of the shaft. This gives CEC screens the ability to increase the length of the stroke and make the screen clear even in arrow-shaped materials and compost. Change the shivs for speed and change the counterweights for length of stroke. CEC has two styles of lubrication for the screen bearing, either running in oil or grease. 5x16 and larger screens have running in oil bearings. You can order running in oil bearings on smaller screens for an optional charge before manufacture. CEC screens, up to and including the 5x14 screen, use an adjustable shaft-mounted external counterweight to cause the stroke. Larger 6x16 and 6x20 screens use both eccentric center shafts and external counterweights. The larger screens have more mass and load than the external weights can handle. CEC screens have strokes that vary from 3/8 of an inch to 5/8 or 3/4 of an inch. The screen shown in this video is the famous Screen It screen and will be running at 5/8 stroke to provide good material feed and product clearing. The second deck of the screen shown has square 1.5-inch cloth installed. The top deck of the screen will have steel plate, 1/4 inch thick with 3-inch round holes. Now let's talk a little about the installation of screen cloth. The clamp rails that hold the cloth in position must pull the cloth tight from the center out to each of the sides. It's possible to have the clamp rail bolts as tight as you can turn them and still not have the cloth tight. Here's a walkthrough of the proper installation procedure. Check all of your crown bar rubber to make sure it's in good working order. Check the crown bar to make sure you don't have any mechanical problems. Example, look for bad wear patterns. Make sure the clamp bar bolts are straight and that the holes are clean and clear. Drop the screen cloth on the deck and check it for proper forming dimension. Screen cloth has a manufacturer's recommended forming width outside of hooks, normally referred to as OSH. This screen has a recommended forming width of 58.5 inches OSH. The difference between the inside of the basket of 60 inches and the 58.5 inch OSH gives you clamping room and allows for cloth stretch. Now let's talk about clearance. Most screens are made for standard wire size. When you go to heavier wire gauges and/or banded wire, you could as much as double the thickness. This new thickness can stop your clamp rails from breaking over the closing arc, so you can tighten the cloth. The clamp rail bolts pull tight, but you've created a new problem. The clamp rail drives down on the screen cloth banding and extra thickness. This bottoms out on the solid steel underclamp bar wedge and causes the bolt to pull tight and the mass to be locked solid. Your first impression is that your job is done. Not so. Your cloth is still loose. You need to remount the clamp bolt wedges to allow additional bolt travel until the rail breaks over. Or you can install a shorter-legged clamp rail for heavy-duty cloth application. CEC can make this for you as a special order. If you're breaking screen cloth down the center of the panel, it tells you that the cloth was not tight. The screen cloth will, without exception, break if it is not properly tensioned and all faces pulled tight on the crown bars. Be certain you've done this properly. It doesn't matter who manufactured the screen basket or brand of screen cloth. If the cloth is not fit properly, it will break. You can have the bolts tight, the clamp rail bottomed out, but still be loose in the center. You think you're okay, but in a few hours your cloth will be ruined. The correct operation is with the rails over center and cloth properly tightened and snug on the crown bars. It's easy to change the cloth size, banding, and screen wire diameter, thereby causing yourself a problem that was not a problem before the change. Look at the ends of the clamp rails and make sure they're over center. Your screen cloth supplier will not replace cloth that is broken down the center. He knows what has happened as soon as you tell him where the cloth failed. Now let's take a look at CEC's drive mechanism. CEC motors mount off the subframe and have a bolt tensioner to adjust the belts. CEC uses multi-groove sheaves and #1 quality belts. Changing the motor sheaves can vary screen speed. Do not do this change without CEC direction. Overspeed combined with improper counterweight combination can cause premature bearing failure or mechanism damage. All CEC screens use cast steel, machined bearing housing, and special screen bearings to assure good life and easy service. The drives are enclosed and the counterweights are guarded. CEC screens are always supplied with subframes that facilitate the CEC rubber suspension system and motor drives. CEC does not use a pivoting motor base. Like several other major manufacturers, CEC uses an offset taper lock and the screen drive bushing to compensate for screen stroke movement. They're much less trouble than spring-loaded tables. The complete screen module is easy to install, comes with underhopper, under conveyor, walkway, railing, kick plates, guards, crown bar rubber, motor, drives, and drive guards. It comes with mounting channels ready to bolt in place. Special discharge lips are not a problem, as long as we get good information from the customer. Remember, your screen is only as good as your maintenance. Lubricate the screen according to your manual. Keep the belts properly tightened and in good shape. Do as we recommend, and you will have long, trouble-free service. Cone crusher rebuild and setup. CEC cone crushers are built around a proven design, using a straight bushing in the main frame, a tapered bushing in the eccentric, and a concave bronzed socket liner to support the head ball. The eccentric is powered by the belt-driven countershaft to a pinion and ring gear drive. The pinion shaft is mounted on tapered roller bearings and has its own oil lubrication reservoir built into the countershaft housing. The countershaft housing bolts into the crusher mainframe and is sealed by O-rings to this housing. The countershaft has lip seals on each end of the pinion shaft to seal the lube oil in the reservoir. The pinion gear is mounted on the tapered shaft, keyed, and locked in place by a locking nut and locking key. The crusher shaft head sits on the socket liner. This bronze liner mounts to the socket assembly and bolts into the mainframe. The sealing ring mounts around this. The ring gear is journaled around the eccentric and is locked by an interference fit. You need to heat the gear in hot oil to create the expansion needed for assembly. It slips over the outside bore of the eccentric and shrinks to the eccentric. You remove a gear by heating the gear from the outside until it drops free. There is a special seat area on the top of the eccentric to seat the gear. The eccentric sits in the mainframe on step washers. The bottom washer is steel, the center washer is bronze, and the top washer is called the steel thrust plate. The bottom washer with lubrication grooves is installed over a dowel pin in the bottom of the eccentric cavity. The top steel thrust plate is dowel pinned to the bottom of the head shaft. The bronze center washer sits within the housing bore between the step washers and the steel thrust plate. Lubrication comes down the eccentric to the step washers. The gear root clearance and gear backlash are adjusted by placing shims under the bottom step washers. These shims are a standard CEC part. Refer to your CEC manual for the proper root clearance and backlash. This setting is very important to assure proper gear life, gear noise, and proper lubrication clearances. Now let's look at the mainframe bushing and eccentric bushing. Both bushings are installed as interference fits. You freeze the main bushing in dry ice to contract its outer bore, slip it into the housing seat, and rotate it so the bolt-in rotational lock can be bolted in. The bushings sit in their respective seats and must be installed so that they are seated in the proper frame location. If you experience difficulty in doing this, consult with the CEC Field Service Manager. The mainframe bushing is a straight bore bushing. The eccentric bushing is a tapered bore bushing to mate with the shaft taper. The shaft depth into this bushing is controlled by the socket and socket liner contact to the head ball. You raise the socket for shaft clearance. The head ball of the cone shaft assembly sits on the socket liner. You need to blue the head ball and install it in the cone. Rotate the head left and right a few inches. This will cause the bluing to transfer to the socket liner. Remove the shaft and check the head ball contact to the socket liners. If you do not have good contact, sand the liner to correct the contact. Please note that the liner is held in place by dowel pins and locked by pouring Babbitt around the pins. CEC cones have a spring-mounted socket sealing ring that has positive sealing contact to the head sealing rings. The interference of this sealing ring mates against the socket sidewalls and has a felt dirt seal. The sealing ring has anti-rotation stops that pivot with the sealing ring and keep it in proper location at the socket. This is a proven seal and has been used for 50 years on thousands of cones, not just CEC menu cones. The socket bolts into the main frame with an interference fit, so it stays tight under its rotation load during crushing. The socket provides two major services to the proper cone setting. The first function is you can shim the socket up or down to set the shaft to eccentric bushing clearance. The second function is to provide a top clearance to stop the eccentric from being lifted upward by cold oil during cone warm-up. This assures that you will not lift out of the step washer pins. Let's look at the cone oil system. Oil enters the center of the eccentric housing and goes to the oil journal of the bushing and the outside of the eccentric. Oil flows upward and downward around the eccentric side and provides lubrication between the main frame bushing and the eccentric. Oil passes through a journal drilled hole in the eccentric into the inside oil passages, lubricating the shaft to eccentric bearing contact. 75% of the oil flows upward, and 25% of the oil flows to the bottom cone oil drain and back to the oil tank. The oil that flows upward exits under the head ball and drains out of the oil exit hole in the outer edge of the socket liner. Oil also feeds up the shaft oil port at the center of the eccentric and under the head ball for additional socket lubrication. All the oil that exits the socket drains into the gear cavity and lubricates the ring and pinion gears. It overflows the cavity into the drain and goes back to the tank. If the oil raises above the standard operating temperatures, it will automatically be routed through the air-to-oil cooler to keep the temperature in the proper operating range. The head shaft has a loose fit into the eccentric bushing. You will have from 0 to 10 RPMs of head spins when assembled properly. The head spin is caused by the oil connection between the shaft and eccentric bearings, not shaft to bushing contact. You can put on a pair of gloves and lightly grip the feed plate on the top of the head shaft. You should be able to cause enough friction to break any oil film and stop the shaft spin. If you cannot stop the shaft, you need to increase the clearance between the socket and the eccentric. This increase of about 1/16 of an inch will usually stop head spin. The cone's head will back up in the socket mounting during crushing. If this does not happen, you need to adjust the clearance. Do not run the cone if the eccentric is driving the head in a spin. The crusher will not feed properly. The manganese liners will wear very fast from the scuffing, and you will weld the shaft and bushing together, thus causing failure. Cones are very easy to assemble if you use your video guide for reference and your cone manual for the exact tolerance of your appropriate model. Follow the CEC oil recommendations and oil change frequencies, and you will have excellent service life. If you have any questions on installation, please don't hesitate to call CEC's service department. We want to be your partner in good performance.
Everyone knows how dangerous a skill saw can be for your fingers, but what about your eyes? You have 10 fingers, But if you lose the use of one eye, you've lost not only the vision in half your face, but almost all your depth perception. You'll be out of work and you'll barely be able to hit a nail with a hammer, much less drive or catch a softball. So protect yourself. Depending on what kind of work you're doing, there's eye and face protection that's right for the job. Of course, if you're welding, you'll need to protect your eyes with a tinted lens. And if it's a two-man job, you must both wear them. Most eye injuries happen to an unprotected assistant. Many other jobs require the use of clear safety glasses or goggles. Always check your eyewear for a few simple things. Number one, make sure they're not broken or cracked. If they are, replace them. Don't try to fix them with tape or something. Get an approved pair. Number two, make sure they fit right. They should fit high up on the bridge of your nose, close to your face, and snug but not tight around your ears. The most common complaint about eye protection is that it's uncomfortable. Doesn't have to be. And number three, make sure they're clean and free of scratches that can obscure your vision. If they're not, take a clean cloth and wipe them off, or use a lens cleaning tissue. Then check them again. Working on a job site can be dangerous if you can't see clearly. So once you have a clean, well-fitting pair of glasses, keep them that way. When you're working and your glasses fog up or get covered with dust, don't try to wipe them off with your fingers, because the oil from your hands can leave a smudge on the lens. Take a moment to clean your eye gear thoroughly with a clean cloth. It'll save time in the end, and it'll be a lot safer. It's not a bad idea to always keep a cloth in your back pocket. When you're finished with your eyewear, be careful where you put them down. Don't drop them or lay them where the lenses could get scratched or pitted. And when you store them, put them in a protective case, or if you don't have one, wrap them in a soft rag. The next time you want to use them, they'll be clean and clear. Now, the same rules apply for cleaning and care if you're using goggles instead of glasses. If you wear prescription glasses, you need to wear goggles over them whenever protective equipment eyewear is required. Regular glasses won't protect you from dust and chips coming in from the sides. Now, some people complain that goggles give them a headache. That almost always happens because they aren't fitted properly. The head strap should be adjusted so there's just enough tension to hold them securely. The strap should be worn low at the back of the head. Lens fog problems can be eliminated by using an anti-fog preparation. Sometimes basic eye protection is not enough, like when you're working with dangerous chemicals. In this case, you'll want to wear a face shield. Notice that you should wear safety glasses underneath the face shield. Choosing the correct protection is only the first part. You have to wear them. Wear them every time. Remember, wear the right eye or face protection for the job. Check to see that they fit right and that they're not broken or scratched. And keep your eye gear clean, free from dust and smudges. Also, use only inspected and approved equipment. Before you start any job, stop and ask yourself, are my eyes and face adequately protected? They're too important to take for granted, so please, don't gamble with safety. The odds just aren't in your favor.
Thank you for watching this CEC service video.